Okay, so good morning.
Good morning.
Okay, so yesterday, so what was our lesson yesterday? Yes, what, yes, we have discussed about patterns and inductive reasoning. Okay, so again, what do you mean by inductive reasoning, Haley?
The reasoning based on the pattern.
Okay, so we say inductive reasoning, it is a reasoning based on the pattern that we see, right? How about conjecture? Yes, Daniel.
Statement based on observation.
Okay, these are the statements that we based on observations, based on the patterns that we see, so we can create a statement, and that is what we call conjecture. How about the counterexample, Noah?
It's the example that makes our statement false.
Okay, so if we have already a conjecture, therefore we can create a counterexample. If it is false, to test if the conjecture is false, so we can have a counterexample that disproves the statement on the conjecture. Okay, so before we start, so let's have first, okay, so let's keep our brain working, guys. So, okay, so you are just going to okay, so you're just going to guess the word based on the pattern or the figure that we have here. So what do you think? We can have more than 2 words. If you know the answer, please raise your hand. Yes. The clue here is we have 2 words. We have letter C, right?
7 C's.
Yes. Your answer is 7 C's. Let's see if your answer is correct. Okay, very good. You have 7 C's because we have 7 C's. That is based on pattern that we see, right? Okay, how about this one? You have 1 point.
Forgive and forget.
We have forgive and forget. We have forgive and forget. Okay? You have already 2 points. Okay, so I can add that one on your test or quizzes. Okay? You can also answer, guys. So let's see if it's forgive and forget. That's right. Next. 2 words. Dun-dun-dun. What is the word? We have 2 words. Observe the pattern. Start with letter M, the first word. Okay. Do you have an idea? Okay. Those are what? Letters, right? And can you see what's missing here? U. So the answer is missing U. Okay, we don't have U on that pattern. Did you see it? Okay. Next. 2 words again.
Downtown.
Very good. We have downtown. Okay, that's downtown, so it's going down. Okay. How about this one? You get 1 point, so just remember your points. So I will add that. Okay? 3 words. 4 words.
Oh gosh.
English. Just read this one. And then the third. That's the clue. That's the first word.
Oh, reading between the lines.
Very good. We have reading between the lines. Okay, the correct answer is reading between the lines. So you get 1 point already. Next. How about this one?
What the heck? Embarrass was yours.
Uh,
I'm not good at these.
2 words. This is the last word.
That's a word.
When,
Hmm?
Oh.
but I don't know what it is.
Okay,
Backwards something.
okay, backward
For-
glance.
backward
Isn't
glance.
it?
Oh
You
my
read it.
gosh.
Okay, you read it backward, so it's glance, so backward glance. Okay, next.
Tricycle.
Okay, that's tricycle. Or, because you have three-sided. Okay? This one.
Jack in the Box.
Jack in a box. That's right.
Green Jack.
Jack
How are
in
you
a
guys
box.
getting this so fast? It's coming on its
Okay,
screen.
just
I'm like,
remember
oh
your
my
points,
God.
guys. And this one, it's very easy. 2 words. Two words. Just read it.
Too touch.
Two touch.
That's not it, but that's okay.
What happens to you?
Touchdown.
Touchdown. That's right. Okay, touchdown. Do you still have? Okay, how about this one? 4 words. Start with start with the word just. Just once? That is just around the corner. Because it's the corner, right?
Oh.
Okay. Okay, this one. Maybe last.
Making the lost time. Something like that.
You miss one.
Oh wait, making up for lost time?
Very
Yeah.
good. So making up for lost time. Okay, as you can see, making up for the lost time. And that's correct. You got your point now. Amber, very good. Okay, how about this one? Crossroads. Oh, oh, answer first?
He's got it. He's got it.
Okay. And still have 3 words.
6 feet under.
What?
6 feet under.
6 feet under? You're almost there. You can answer, guys.
Yeah, would answer if I knew the answer.
The answer is
Oh wait.
yes.
6 feet below ground.
Below ground
Underground.
or underground.
Ah.
It's
Same
it's
thing.
Same thing. 6 feet underground or below ground because under the ground. Okay, so it's underground. Maybe this is the last one. There's a lot. So maybe it's okay now. So next time we can have all this one. Okay? So that's all about patterns, right? So as you can see, we have patterns not just in sequence of numbers. We also have words, and at the same time, we also have patterns on drawings. Okay? So for today, so we are going to discuss about, okay, so the next lesson, so can you have your book on page 89. Okay, so our next lesson is all about conditional statements. Okay, so conditional statements, okay, can you use the word study and pass the test using the if and then statements? Anyone in this class who can use the word study and the second word is pass the test using if then statements? Yes, Daniel.
If you study, then you pass.
Very good. If you study, then you pass the test. Right? And that is an example of conditional statements. There is a condition. Okay? So there is a condition. And we are using if and then to connect the statement or the words to form a statement. Okay? And here, if this is our hypothesis, and then we have this one as our conclusion. So on our statement, if you study, then you pass the test, what is our hypothesis? Amber.
If you study.
If you study. So our hypothesis is you study, right? And then our conclusion is what? Noah.
Then go past the test.
Then you pass the test or pass the test. Okay. And we can have this one, P, the hypothesis, implies Q, where P is our hypothesis and Q is our conclusion. Did you get it? Okay, so these are the parts of the statements. We have two parts of our statements. First, we have hypothesis, and the second one is conclusion. Okay, so let us, for example, if a polygon has 8 sides, then it is an octagon. Can you identify what is our hypothesis on that statement, Haley? If a polygon has 8 sides, then it is an octagon.
If a polygon has 8 sides.
Okay, but if we are going to identify the hypothesis, we are not going to use the word if. A polygon has 8 sides, that's our hypothesis, and then our conclusion is octagon. It's an octagon, right? Can you give me another example of statement that uses if and then? Aside from the example that we give, can you give me another example of statements? Even if it's not related in math, do you use the word if and then statements in your daily life? How about Noah? How often do you use the word if and then?
I don't know.
You didn't use that.
I mean, it probably did.
Probably, right? Because it's part of our statements. For example, me, if I have passport, then I can go to other country. Because I have my passport. The hypothesis is I have my passport. Then the conclusion is I can go to the other country. That's the reason why I'm here. Right? How about Haley? Can you give me an example of conditional statements?
If you have a whiteboard marker, then you can write on the board.
Okay, that's right. Also, if you know how to play volleyball, then you are a player, volleyball player, right? Okay, so something like that. Okay, so we have here the diagram for the conditional statements. Okay, so we have here P is our hypothesis, is part of our conclusion. Okay, so just like for example, a while ago, so we have our hypothesis, we have study, then we pass the test. So pass the test is our conclusion, so therefore, so we can say that the study is part of the conclusion, passing the test. If you study, then you pass the test. Okay? So we have here, I think, problem number 1. So on the next page, identifying the hypothesis and conclusion is very easy, right? But sometimes we have an example that we don't have the word if and then. So we are going to identify what would be the conclusion and what would be the hypothesis. Okay, so for example here we have an animal is a robin, then the animal is a bird. So as you can see, our hypothesis here is what? Do you know what's robin? Yeah, that's an animal, right? Then what animal is that? Bird. That would be our conclusion. Okay? So how about what are the hypothesis and the conclusion of the conditional? If an angle measures 130 degrees, then the angle is obtuse. So what would be our hypothesis here? If an angle is 130 degrees, then it is an obtuse angle. What is our hypothesis?
An angle measures 130 degrees.
Okay, an angle measures 130 degrees, and our conclusion is
It's obtuse.
it's obtuse angle. Obtuse, not obvious. Right? Okay. Next, problem number 2. Writing a conditional statements. So how are we going to write? For example, we have here the definitions. So we can write that one using conditional statements. For example, a polygon that has 6 sides is hexagon. Can you create a conditional statement based on the definition that a polygon that has 6 sides is hexagon? Yes? Amber. A polygon that has 6 sides is a hexagon. Can you make a conditional statements using if and then based on that statement?
If a polygon has 6 sides, then it is a hexagon.
Very good. Okay, so if a polygon has 6 sides, then it is a hexagon. Okay, so we have here truth value of a conditional. So the truth value of a conditional is either true or false. Okay, it can be true or it can be false based on the statement that we give. So not all the time it is true. Okay, for example here, if a woman is a Hungarian, then she is European. Is this true or false? Problem number 3. Yeah, that is true. How about number 2? Letter B. If a number is divisible by 3, then it is an odd number. Is it true or false? False. Why?
Because there's like 6.
Okay, isn't it? We have divisible of 3, 6, 9. And 6 is not an odd number. So therefore, the statement is not true. So our conditional is false. So not all the time it's true. Okay? So we have here conditional statements. So we also have 3 statements here we can create based on our conditional statement. The first one we have converse. The converse is if Q, then P. Okay, so our example a while ago we have if you study, then you pass the test. Okay, we can create the converse of these statements so by just interchanging the hypothesis and the conclusion. So what would be our converse of this statement? Again, what is our hypothesis here? You study, right? And our conclusion is
Yes.
you pass the test. How are you going to write this one now? In converse. Yes, linear.
If you pass this test, then you have studied.
Okay. If you pass the test, then you study. That's right. Is still true? If you pass the test, then you study. Okay, so aside from converse, we also have here contrapositive. Contrapositive statements we have here if Q, if not Q, then not P. So by the way, this is Q implies P, our converse. Q implies P. 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 Okay? So we have here the contrapositive. If not Q, then not P. So it's the opposite of what? The contrapositive is the opposite of our conditional statements. Okay. If you studied, then you passed the test. So what is our contrapositive here? So we are going to negate. The word not will be used now using these statements. Okay? So we have here, if you study, then you pass the test. How are you going to use then to negate that statement using the word not? Not. Yes, Amber.
If you did not pass the test, then you did not study.
If not Q, right? So it's what is our Q here? Pass the test. So you answer if you did, what's your answer?
If you did not pass the test, then you did not study.
That's right. If you do not,
Did not.
okay, if you did not pass the test, then you did not study. That's right. That would be our contrapositive. So that is just the opposite of our conditional, converse or conditional. If not Q, it's the opposite of our converse, right? The negation. Negation. Is it converse? We have if Q, then P. Is it did not pass the test? The contrapositive. Where is our Q here? Right? Pass the test. Okay, that's correct. Then you did not study. That's right. Okay, we also have here inverse. The inverse here is if not P, then not Q. So we have here the symbol for negation, this one. This is the symbol for negation. We have if not Q, it implies not P. So that is our contrapositive. Now we have here the inverse. So we have here negation. When we say negation, it's the negative one of our statement. The opposite. If not P, implies not Q. So how are we going to construct our inverse now? Yes, Daniel. If not P, then not Q.
What do you want me to do for the sentence that we did?
Yeah. So we are always basing on our P,
Okay.
right?
Um,
And Q. What is our P again? You study, right? And our Q is
You passed.
pass the test. Okay, if not P, then not Q.
If you did not study, if you do not study, then you will not pass the test.
Okay, that's right. So if you do not study, then you will not pass the test. That would be our inverse. See? Okay, the statements contrapositive and the conditional statements, these two are equivalent statements. Just observe. The conditional, we have P implies Q. Okay? And if not Q, then not P are just the same statement if you're going to analyze. And they are called equivalent statements. On the other hand, we also have converse and the inverse are also equivalent statements. So if the conditional statement is true, remember, if the conditional statement is true, therefore our contrapositive is also true. But if it is false, our conditional statement is false, then therefore our contrapositive is also false. And if our converse is true, then the inverse is also true, because they are equivalent statement. If it is false, then it is false also, the inverse. Okay? Okay, so I have here a statement. So we are going to create the converse, contrapositive, and inverse. A number is even if it is divisible by 2. That is our statement. A number is even if it is divisible by 2. So this will be our conditional statement. So what is our hypothesis here, or our P?
A number is even.
Yes. A number is even. How about conclusion? Sorry, if a number, then... So our conclusion here is, okay, it is divisible by 2. So therefore, if a number is even, that is our P, or the hypothesis, then it is divisible by 2. This will be our Q. Always remember, Q is the conclusion. If we have the word then, so the phrase after it will be our conclusion. So what would be our converse here? So in identifying our converse, contrapositive, and inverse, so we should identify first our hypothesis and conclusion. Again, what is converse? We have Q implies P, right? Okay, how are you going to construct the converse of the statement?
If it is divisible by 2,
Okay,
that number is even.
okay, very good.
That number.
So we are just going to interchange the conclusion and the hypothesis using word if and then. So the answer is, if it is divisible by 2, then it is an even number. How about our contrapositive? So again, what is our contrapositive? We have if not P, then not Q. So we always base on our conditional statement. Remember. So we are not going to base on our converse now. Okay? So what would be our contrapositive now? Amber.
If a number is not even, then it is not divisible.
Okay, very good. So we are just using the word not to negate the statement. If a number is not even, then it is not divisible by 2. Is it true or false? our contrapositive. If a number is not even, then it is not divisible by 2. True or false? If a number is not divisible by 2, then it is not an even number. True or false? True, right? So therefore, true. This is also true, right? As I have said, they should be have the same truth value. If this is false, then this would be also false. How about the inverse now?
Wait, I have a question.
Mm-mm.
Over there it says if not Q, then not P for contrapositive.
Yeah, and I looked
Where?
it up and that's right. That's not right. It's if not Q, then not P.
Yes. If not Q, this is not, we interchange. Right? If not Q, then it's not P. Okay? So we are just going to remember this one. So the converse, if Q, then P. The contrapositive, if not Q, then not P. Okay? But as you can see, we are just, the converse and the contrapositive goes in the same way, but it's just the word not. But always remember the conditional statement and the contrapositive are the equivalent. But these two are not equivalent statements because converse is different from contrapositive. So it can be, the converse can be true and the contrapositive is false. It's going the same way. Okay? Next, how about our inverse? We have, if not P, then not Q. So how are you going to construct our inverse based on the statement? Yes, Noah.
If a number is not even,
Mhm.
then it is not divisible by 2.
Okay, if a number is not even, then it is not divisible by 2. Is it true or false? True. So therefore, all statements are true because, yeah, we test it using the truth value. Okay, how about this one? Can you create, using this word, you create if and then statement, the word Sunday and church day. The word Sunday and church day. How are you going to create a statement using if and then?
If it is Sunday, then it is a church.
Okay, we can say if it is Sunday, then it's a church day. And what would be our converse for that statement?
If it's a church day, then it is Sunday.
Yeah, if it is church day, then it is Sunday. So it's just we just interchange the conclusion and the hypothesis. But still, we are using the word if and then. That's the condition. That's why this is called conditional statements, because we are using if and then. How about the contrapositive of that statement, Haley?
If it's not a church day, then it's not Sunday.
Okay, if it's not church day, then it's not Sunday. And the inverse is just, if not Sunday, if not a church day, if not Sunday, then it's not a church day. Okay? So have a good day.